Scientists are tracking changes in the giant supervolcano that lies beneath Yellowstone National Park, but they say there's no need to worry right now. The western portion of the Yellowstone caldera is shrinking, said Ninfa Bennington, a volcanologist with the U.S. Geological Survey. The caldera is a large volcanic crater left over from Yellowstone's last major eruption. The discovery means that the future of volcanic activity at Yellowstone is in the northeastern part of the park, and there's no chance it will erupt anytime soon. The volcanic system is not capable of producing such an eruption. For now, Yellowstone's mud pots will continue to boil, hot springs will continue to steam, geysers will continue to erupt, the earth will continue to shake, and fumaroles will continue to erupt. The massive underground magma pool beneath the historic park is still red hot, ranging between 1,247 degrees and 2,512 degrees, Bennington said. Yellowstone is one of the planet's largest volcanic systems, where a plume of Earth's molten core rises through the solid rock of the crust, heating and melting it to form a reservoir of magma 2.5 to 30 miles below the surface. In the past, it was often described as a single lava lake beneath the volcano, but newer mapping and imaging techniques have made it possible to see the complex system of reservoirs where the magma collects. Imaging techniques that have produced more accurate maps of the park's vast magma reservoirs show a large, deep pool of magma leading to a shallower one closer to the surface in the northeast, which connects to the park's famous hydrothermal system. To figure out how likely a volcano is to erupt, volcanologists calculate something called the melt fraction. That's the ratio of how much magma there is to the total volume of the crust. Think of the Earth as a sponge, except instead of water filling the holes and crevices, it's molten rock. In volcanically active areas, there's a higher proportion of magma to the ground. The higher the proportion of magma, the more likely an eruption is in that area. The mapping was done using magnetotellurics, which measures the electrical conductivity of what's beneath the Earth's surface. Molten rock, called magma, is an excellent conductor of electricity, making it possible to map the precise area where the magma is stored. The tests, conducted over several months by scientists from the USGS, Oregon State University, and the University of Wisconsin-Madison, showed that while there are several very large reservoirs of magma beneath Yellowstone, they are separated from each other. It would be difficult to mobilize the magma in a single eruption because they are not connected. It is still possible that the northeastern part of the park could erupt in a major explosive eruption similar to the one that occurred at Yellowstone 2.1 million years ago. In that event, volcanic ash reached from the Pacific Ocean to Canada and Mexico. Such eruptions tend to recur every 600,000 to 800,000 years, according to the U.S. Geological Survey. The last one occurred 640,000 years ago. It was known as a supereruption because it released about 250 cubic miles of material, 1,000 times more than the eruption of Mount St. Helens. Mount St. Helens in Washington state in 1980. Right now, the sponge is not full enough of magma to support an eruption. For that to happen, the system will need more magma to fill more of the crustal sponge. Once the system reaches a significant portion of the magma-filled space, an eruption could occur. But we're not there yet. We're talking about geologic timescales. That's hundreds of thousands of years and probably much longer, Bennington said.